Okay. So, number one, use the table above to estimate the total distance traveled at t equals 15. Okay. All right. Now, a lot of you probably, on number one, probably plotted these points, right? Is that my guess? No? You didn't? Okay, well, I'm going to do it, and then I'm going to show you the correlation between it. You really don't have to, but I do want to make the connection. That's why I'm doing it. Okay, so 5 is there. 10 is 18, so maybe there. Shh. It's fine. 15 is 10, so something like this. Okay, so maybe the curve connects these somehow. We don't know how it connects, right? Because remember what I said, tables don't give us all information, it just gives us points on the graph, right? The curve could be going crazy. But those are the only points we have. And if you want to visualize a curve, that's fine. But first thing you have to know is how many subintervals do you want? You want 3 subintervals. How wide is the whole thing? The whole interval is 15, because we're going from 0 to 15, right? So how wide is each subinterval? 5 units. And so conveniently, I gave you the data points for each, right? If this was 4, it'd be kind of weird to do because they wouldn't be equal subintervals. Okay? So that's that. So we're going to draw vertical lines to get our rectangle started. Okay? We know that the width of each rectangle is 5. And the way we express that work is we would say the total interval divided by 3 subintervals, which is 5 each, right? Now, the next question is, what is the height of each rectangle? What type of approximation are we doing? A right hand. So you have to go through it step by step. Don't try and overassume or overthink. It's actually very simple. In this rectangle that I'm going to form, you have a curve where this is the end of one of the rectangles, and this is the other end, in a sense. Which one of these points should I be using to determine the height? The right hand, because it's a right hand approximation. So that means I'm going to draw my rectangle so it hits this point, not this point. And which way am I going to draw it? To the left, because I want this rectangle. Does that make sense? Okay. Now we go on to this rectangle. All right, am I going to use the point to the left or the point to the right? To the right, because we're doing right hand approximations. And what about this one? To the right again, right? Everything's to the right because you're doing a right-hand approximation. So now we're going to figure out the area of each one. It's going to be what? 5 is the width of the first one times 21 plus 5 is the width of the second one. Some students will want to say 10 because the 10 value is there. That's not the case. It's how wide is the rectangle. So it's the distance between 5 and 10, not the coordinate. 5 times 18 plus 5 times 10. And then we figure it out from there. That's 105 plus 90 plus 50. So it's 140, 245. Okay, now, what did I just find there? Remember, there's 2 types of questions that I could ask here. I could ask for the distance traveled or the location or the position of where it's at, right? What is this? This is the distance traveled. Okay. What would I need to find the position? The starting point, the initial condition. What am I asking for? Distance traveled. Was there any units on here? No, so the answer is 245. Okay. Now, let's try and understand that in terms of the table instead of the graph, because you've got to be able to quickly do this. So let me rewrite the table real fast. T and V of t. And the other thing is, be careful here. Make sure the graph or the information I gave you was velocity. Distance is only going to be given or found when you have the velocity information, right? If I give you the distance information, if this was, just as a side note, if this was the position and you started at home or something like that, and the numbers were 10 there, how far did it travel at t equals 15? 10, because this is the distance traveled, right? So make sure you're talking about speed or velocity in this case. Okay, let's look at this in terms of the table so you can kind of see what to do in maybe an easier way. If I'm cutting this table into 3 equal subintervals, again, how wide is each subinterval? 5. So really, what we're doing is we're saying this is one rectangle, this is another, this is another. You guys see that? So this rectangle is how wide? 5. And then which one do I use? I use the right-hand one. 5 times 21. This is the other rectangle. How wide is it? 5. Which height do I use? 18. This is the other rectangle. How wide is it? 5. How tall is it? I use the right-hand value, so 10. So it's the same thing. It's just actually a little easier to look at on the graph, on the table. You get that? But you have to be able to know how to draw it on the graph too. So any questions? No? Number 2. You guys were all dying on how to take a derivative. There was an easy way to do this. Did anybody know the easy way?
Yeah.
Erica, maybe?
You do ln of the top.
You could do that, yeah. Using the rules of logs. If you know your Algebra 2 stuff, this problem is really easy. But I'm going to do it the long way because I want to make sure you're good. If I'm finding dy dx, I'm just taking the derivative. What is the derivative of log? What did I tell you to deal with log? I told you to put ln of a to the sine x over ln of a, right? You rewrite it? Now, the natural log of a is what? It's a constant, so I'm going to rewrite it as 1 over the natural log of a times the natural log of a to the sine x. You guys follow me? Now, this is a constant, so ignore it. What is the derivative of natural log of anything? So it's 1 over a to the sine x. And then times the derivative inside. What's the derivative of this what kind of function is that? So what's the derivative of exponential? Natural log of the base. So we're looking at this piece right now. Natural log of base times the function, right? And then times the inner of that. So a lot of chain going on. And then we saw this constant over here, right? So 1 over natural log of a. So simplify. The natural log of a, the natural log of a go away. A to the sine x, a to the sine x go away, and you're left with cosine of x. Okay, obviously the quicker way would be to rewrite it as sine of x times the log base a of a. What is log base a of a? It's 1. It's a raised to what power is a? It's 1. So y equals sine of x. So y prime equals cosine of x.